Okay, our last video is going to deal with dimensional analysis. What is dimensional analysis? Dimensional analysis is the ability to change from one unit to another unit via equivalence statements. So what is an equivalence statement? Well, from our American units of measure that our parents grew up with and that most of you may have grown up with, where we're measuring inches and feet and yards and things like that, and gallons and quarts and pints and cups and all of those kind of things. We have a lot of possible equivalent statements. So let's look at those. Here's in distance measurements. 12 inches is equal to 1 foot. 16 ounces is equal to 1 pound. Let's see. 36 inches is equal to 1 yard. 3 feet is equal to 1 yard. 2 cups equals 1 pint. And 2 pints equals 1 quart. And how about 4 quarts equals 1 gallon? And there's many, many more in our system of units. But in the International Standard Units of Measure, called SI, the length or the measurement of distance is called a meter. And we call this the metric system. And in science, you're going to use the metric system a lot. Time, if we're dealing with time, we're going to have time is going to be seconds, minutes, hours, days and years. And you might have months in there too, and weeks, days, years. You could also have weeks and months in there for your time. Volume in liquid is equal to liters. Or we would use ounces and quarts and cups and so on, okay? Whereas mass or weight is equal to grams in their system, where in our system we would use ounces and pounds and then tons, okay? And then density is what influences the weight of things. Density would be mass divided by volume. Okay, so that can be used as part of your dimensional analysis. Okay, so as we look at this, when we're working with the metric system, meter, 1 meter is your middle one. It's the one that everything is based on. Either where so many equals a meter or so many meters equal the other. So let's look at this. If I have 1 meter, if I have 10 meters, 10 meters is equal to 1 decameter. And And this is sometimes called deca. Let's see. Dam. Yeah, 1 decameter. 100 meters is equal to 1 hectometer. Okay? And usually HM would be your parentheses for that. This is decameter, and it is called DAM. And this is just an M for meters. If I have 1,000 meters, this one is 1 kilometer. And I know you've heard of those. And the abbreviation is KM. Now, if I have going the other direction, I have 10 decimeters is equal to 1 meter. And decimeters is dm. And then I have 100 centimeters is equal to 1 meter. And this is cm. And then I have 1,000 millimeters is equal to 1 meter. And this one is mm. So you see, everything is based on powers of 10 when you're dealing with this. And so it makes it really nice to be able to do that. All right? So if I wanted to know how many meters, 100 meters, equals how many kilometers? Well, let's look. I have 100 meters, and we're going to put it over 1, multiply that by the equivalency statement. Well, how many meters are in 1 kilometer? It's 1,000 meters in 1 kilometer. So my 1,000 goes on the bottom, and my 1 kilometer goes on the top. You can flip these back and forth. Since I have 100 meters in my numerator, I have to have my meters in my denominator, because that permits your units to cancel out. Meters divided by meters is 1. So 100 divided by 1,000 is going to give you what? Well, 2 zeros, 2 zeros. You have 1 over 10, which is 1/10, so this is 0.1 kilometers. 0.1. A lot of people just like to count up, and you can do that, but I don't like to do that. I like to work with this system because you can apply it everywhere. So let's look at this with more of them. If I have 1,000 millimeters, and I want to know how many kilometers that's going to equal. Well, in this case, I am actually going to go from millimeters to meters and then meters to kilometers. So we're going to start with our 1,000 millimeters over 1 times my equivalency statement is 1,000 millimeters equals 1 meter. So my 1,000 is going to go on the bottom, and that's 1 meter. You see that? My millimeters cancel. And then times, my next one is going to go from meters to kilometers. So there's 1,000 kilometers. No, there's 1,000 meters in 1 kilometer. Let's get this right. So now my meters cancel, and what's I'm left with? Well, 1,000 divided by 1,000 is 1. And I have 1 over 1,000, which is going to give me 0.001 kilometers, because that's 1/1,000th. Now, I have a paper that gives you all the way up to gigabytes and micrometers and all of this kind of stuff is available. And I'm going to let you look at that on a piece of paper if you would like. I will leave that behind for that to be here. Okay. But we can use this in all kinds of things. In your lab for chemistry, if you have Miss Bobby, she will give you a very interesting and fun experiment with dimensional analysis. And you'll do things with so many cookies as this, and so it's really a lot of fun. And I'm not going to do it because I'll spoil it for her. Okay? But we can take this even to things that we would do in our everyday life. What if I wanted to find out something like if I was going 10 miles per hour, which is 10 miles to 1 hour, and I wanted to know how many feet per second that was, okay? So the first thing I'm going to have to do, I have to do my equivalencies. I can do hours to minutes and then minutes to seconds, right? Because 1 hour equals 60 minutes and 1 minute equals 60 seconds. So that's my two equivalencies I need to go from hours to seconds. Miles to feet. Well, let's see. 1 mile is equal to, and I know my yards because there's 440 yards in a quarter mile, so that would be 1,760 yards, and 1 yard is equal to 3 feet. So if you don't know the number of feet in a mile, not a problem. Go with what you know. So let's see. We can start with either miles or we can start with feet, with hours. Let's start with miles. So I have 1 mile, has to go on the bottom, and a mile is 1,760 yards. And now 1 yard is equal to 3 feet. So you see your miles cancel the miles, my yards cancel my yards, and I'm left now with feet on the top because we want feet per second. So feet has to be in the numerator. Now we need to also change our hours to seconds. So let's see. 1 hour is on the bottom, so my 1 hour has to go on top, and my 60 minutes has to go on the bottom, and then times 1 minute to 60 seconds. Now notice, the hour on the denominator cancels the hour in the numerator. The minutes here cancels the minutes there, and you're left with what? Well, we have seconds on the bottom, and you have feet on the numerator, which is exactly where we want to be. So all we have to do to find this out now is multiply this times this times this, and then on the bottom, 60 times 60. Well, this is 3,600. That's an easy multiplication. The other one, let me grab my calculator to do that one. And this is where calculators are handy. So 10 times 1760 times 3 is equal to 52800. Okay, well, we can cancel out these zeros, and that gives me 528 divided by 36. And that is giving me 14.67 feet per second. Okay? So if I'm going 10 miles per hour, which good marathoners can do, they can run at 10 miles per hour, means they're going 14.67 feet per second. That's quite a bit. It's pretty cool to find that out. So this is how you do dimensional analysis. You start and you find out your equivalencies, and then you look to see where you're beginning and where you have to end up. And in your chemistry, you're going to do a lot of things where you're going from grams to moles. And you're going to go moles to grams. So you're going to go both directions on these. You're also going to go moles to things like number of molecules in a compound. And this all uses this dimensional analysis of moles to number of atoms in an element. Okay? A compound is what has combined elements together. An element is just one of them off the periodic table. Okay? Now, I'm not going to go into this on this video because this is something you will learn how to do in your chemistry class. If you don't learn how to do it, be sure to get help and be sure to ask. The grams, you will find the grams for each element on your periodic table. You will also be able to figure out the grams for a compound by finding the weight of each element in the compound and the numbers that go with that and adding it all together. And then you'll find the amount of grams in a compound. And your equivalency is 1 mole is equal to that total of the number of grams in a compound. Or the mole of a single element is equal to whatever that gram mass weight of that particular element is. So you're going to use this kind of work, this dimensional analysis, with all this kind of stuff. Okay? So if we were to look at it, just briefly, I'm going to do one compound for you. We're going to look at water, just for kicks, to give you an idea what you're going to be looking at here. Water is H2O. This means I have 2 atoms of hydrogen combines with 1 atom of oxygen to make water, okay? So the gram mass of hydrogen is 1.008, okay? The gram mass of oxygen is 15.999. A lot of times we use 1 for hydrogen and 16 for oxygen because it rounds up to that. Yes. Now notice I have them at the same amount of significant digits of addition and subtraction, right? So what's going to happen? I need 2 of these. So this will be times 2, which gives you 2.016, plus 1 of these, 15.999, and that means this compound is going to be 15, 16, 17, 18, 5, carry my 1, 10, 11, 0, carry the 1. Okay, 18.015 grams is how much is in there. Now, if I asked how many moles are in, and this is equal to 1 mole. So 1 molecule of water, H2O, has 18.015 grams in 1 mole. That's your equivalency statement. What if I said if I have been given 45 grams of water, how many moles is that? Well, your dimensional analysis now is going to take this equivalency ratio, your equivalency, and since my grams are on the top, my grams have to go in the denominator, and I'm just going to do G and H2O, and then this is 1 mole of H2O. So we're going to find out how many moles of H2O we have. In other words, this times 1 is this, 1 times this is this, so I'm simply going to divide 45 by 18.015. 45 divided by 18.015, and that's going to give me, it has to be 2.4979, and I've got two significant digits, so I'm going to go 2.5 moles H2O. Okay? That is the way it would work in chemistry. It's doing exactly what I did with units of measure and time, only now we're working grams to moles. And as I say, it gets more and more complex, but the principle is the same. Equivalency statements that are used to move from one to where you want to end up. And have fun with it, guys.